textbook problems. Now let's start with the first problem given. The specific reaction rates of chemical reactions are 2.45 into 10 to the power minus 5. That is, K1 value is given 2.45 into 10 to the power minus 5. The unit is S power minus 1 is given. It is at 273 Kelvin. That is, T1 equal to 273 Kelvin. And 16.2 into 10 to the power minus 4. It is K2. 16.2 into 10 to the power minus 4. S power minus 1. And they gave the net at temperature 303 Kelvin. So, at 273 Kelvin, the rate constant K1 is 2.45 10 to the power minus 5. At 303 Kelvin, K2 is this value. The question is, calculate the activation energy. This is the question. You know very well that the log of ratio between K1 and K2 can be written as, let K2 by K1 equal to EA by 2.303 R T2 minus T1 by T1 T2. This is the formula for this. Substitute the corresponding values. Log of 16.2 into 10 to the power minus 4 by 2.45 into 10 to the power minus 5. EA has to be found 2.303 into the R value has to be taken as 8.314. Then substitute the corresponding values. 303 minus 273 by 303 into 273. Here, the 10 to the power of minus 5 will go to the numerator and become 10 to the power of 5. Already 10 to the power of minus 4 is there. So 10 to the power of minus 4 into 10 to the power of 5 leads to 10. So, log of 10 into 16.2 will become 162. 162 by 2.45 and EA by 2.303 into 8.34. 303 minus 273 leads to 30. The denominator, yes, if you simplify this and cancel and rearrange, you are getting EA value. So EA equal to EA equal to 96116 joule per mole. It has to be converted into kilojoule per mole, which means it has to be divided by 1000. Our EA equal to 96.116 kilojoule per mole. Understood? This is the first sum. Then the second sum, we are going to deal with second sum. First sum is over. The second sum. Rate constant of a first order reaction is 0.45 second power minus 1. K value is given 0.45 s power minus 1. This is the K value. Calculate half-life period. That is T off has to be calculated. What is T off value? 0.693 by K. Substitute 0.693 by 0.45. The answer is 1.54 s power minus 1. So the unit, here you are finding time T off. So second, 1.54 second. Shall we see the third one? Actually, in third one, they have asked one question. What are zero order reactions? Zero order reaction in which the rate of the reaction is not depending on the reactant. Whenever rate of the reaction is not depending on the reactant, then it is called zero order reaction. Then they have asked to find the unit of first order, third order and zero order reaction. Already we took under different titles. Now let's go to the fourth sum. Fourth problem given in the textbook. Fourth problem. If 30% of a first order reaction completes 25% of reaction in 100 minutes. That is, in 100 minutes, 25% of the reactions have been completed. Then, what are the rate constant and half-life value of the reaction? This is the question. Since 25% have been completed, A has been taken as 100. A is 100. Then, X equal to 25. Up A minus X is 100 minus 25 equal to 75. Time is given. What is the time? 100 minutes. The question is K. What is K? 2.303 by T log of A by A minus X. Substitute all the values. 2.303 by 100 log of 100 by 75. Cancel. 175. 100 can be taken. 175 can be cancelled off. 4 times, 3 times. But 2.303 by 100 log 4 minus log 3, because log 4 by log 3. The result will be 2.877 into 10 to the power of minus 3 minute power minus 1. This is the K value. Since time is given in minute, it can be proceeded like this. Then fifth sum. We will enter into the fifth sum now. If 30% of your first order reaction is completed in 12 minutes, that is T is 12 minutes, what percentage will be completed? A has been taken as 100. X is 30. Up by A minus X equal to 100 minus 30 equal to 70. Then T equal to 12 minutes. T equal to 12 minutes. Substitute in the formula. K equal to 2.303 by T log of A by A minus X. K equal to 2.303 by 12 log 100 by 70, 0, 0 cancel. Log 10 by 7 you are having. Actually, the time has been allotted. The A is 100 and A minus X is 70. Upon substituting all the values, the answer will be 2.98 into 10 to the power of minus 7. The K is 2.98 into 10 to the power of minus 7. Minute power minus 1. It has to be compared, this answer has to be compared with the real one. Let's proceed. .98 equal to, once again compare with the value, 2.303 by, now they gave the new value. The new value is 65.33, and they have given 65.33 log of A by A minus X. Rearrange. Log of A by A minus X equal to, already 2.98 into 10 to the power of minus 7 is there, 65.33 by 2.303. Of a log of A by A minus X equal, take log values and subtract, followed by anti-log values, 0.845 we have got. You know the A value, A has been taken as 100. Of a log of 100 by 100 minus X equal to 0.845. Rearrange and calculate the X. Then the X will be, then the X equal to 85.7%. Since percent involves, we have written like this. Shall we go to the question number 6? Now the question number 6. Show that for a first order reaction, time required for 99.10% is about 10 times the half-life period. We discussed, we taught already. Then half-life of a seventh question. The half-life period of a first order reaction is 10 minutes. That is T of equal to 10 minutes. The time taken to become half of the value is 10 minutes. What percentage of the reactant will remain after 1 hour? They have asked us to calculate 1 hour. So, T of under 10 minutes. Number of half-lives. Number of T of in 1 hour equal to, you know we will get 1 hour as 60 minutes. So 60 by 10, 6. So totally there are 6 half-lives. Now look here. Suppose initially 100%. In first half-life it became 50. In second half-life it became, of course, half of this, 25%. In third half-life 12.75. In fourth half-life 12.5 by 2. 6.25 half-life. Then fifth half-life, once again it became half of this, 3.125%. In the sixth half-life, once again it became half of 1.5623%. This is the last value has been obtained. Shall we see the last question in this chapter? Seventh question. The initial concentration is given. The initial concentration is 5.2 into 10 to the power of minus 2. Eighth question. Eighth question. The initial concentration of a first order reaction is 5.2 into 10 to the power of minus 6. Rate equal to 5.2 into 10 to the power of minus 6 mole per liter per second. At 298 Kelvin, when the initial concentration A is given, A equal to 2.6 into 10 to the power of minus 3 mole per liter. Question is, calculate the first order rate constant of a reaction. You know very well that rate equal to K1A. Upper K1 equal to rate by A. Rate is 5.2 into 10 to the power of minus 6. This is 2.6 into 10 to the power of minus 3. Shall we cancel these two by 2 times? The 10 to the power of minus 3 will go to the numerator, become 10 to the power of 3. Upper K1 can be written as 2 into 10 to the power of minus 3 S power minus 1. That's all. So, chemical kinetics 2 is over.